Hey, back at it again. Here we go. More solving of quadratics, but not the Algebra 2 F word this time. So we are going to be doing square roots this time, okay? So quick review on how to simplify radicals. This is more of an Algebra 1 type topic. And basically, we're looking for two numbers that multiply to the number underneath, but find the biggest perfect square factor, unless it's already a perfect square. So you'll notice across the top of the page are your perfect squares. Okay, there they are. 1 squared, 2 squared, 3 squared, and on up to 20 squared. So here's the biggest deal with this. When you're trying to simplify radicals, you're trying to find one of the numbers in this list has to be one of your two factors. Okay? So like with 18, I can't use 6 and 3. I don't see 6 or 3 in the list. Okay? Technically, could I use 1 and 18? I'm going to actually cross out 1. Yes, it's a perfect square, but it's not going to help me at all. So what number in that list goes into 18? 9. Okay? All right, here comes funky hard logic. You ready? Only the number that's in radical jail that's having perfect behavior gets out. The square root of 9, since it's a perfect square, 3. And again, if you want to, this is 2 squared, 3 squared, 4 squared, 5, 6, 7, 8, 9, 10, and so on. Square root of 9 is 3. The other one doesn't break down nicely, so it has to stay in radical jail. It is acting irrationally. And if you just understood that was a math joke, good for you. Because square roots are irrational numbers. Okay. Are they all going to be that straightforward, though? Not exactly. Because people get to numbers like number 2, and they're like, okay, 4 goes in. I mean, they check. They're like, okay, 48 divided by 4, faces in the way again, is 12. Here's the problem. Is that the biggest one? Okay, we're going to make a note here to the side. Okay, 4 and 12. I'm going to 4 and 12. Okay. Can you find one that's bigger? The answer is yes. There's a bigger one, 16 and 3. And I'm going to show you why that's important right now. Again, the big perfect square, 16, gets out of radical jail. The 3 does not. So why does it matter, Hardy? Why can't I just do 4 and 12? Okay, let's do 4 and 12. Square root of 4 is 2. 2 square root of 12. Not the same thing. Now, some of you at this point have typed it into your calculator already and said, Hardy, though, mathematically, I get the same decimal with both of these. That's true. But that's the same thing as saying, well, is it 2/4 or 1/2? They're the same thing, but we reduce. If this was an SAT test or, let me think, an ASVAB test or something like that, that's going to be the answer you see. You're not even going to see this as a choice. So if I go this way, how do I know that this one isn't quite ready? Here's how. If you look at 12 and look at this list, you see a number in the list that can go into 12? Oh. See, I can still break the 12 down. So this now becomes 2 times 2 square root of 3. I can get to the same answer? But who wants to do all that? Nobody. We're already talking all the time about, how can I make this go faster by getting the biggest perfect square? We don't want to do that, so we're going to throw that somewhere. Okay. And so we keep doing these. Now, I'm going to skip number 3 for right now. I'll put the answer down at the end. Maybe that's one you can pause me and check later. You're like, ooh, fraction, what do I do? Treat it just like you would if it was 2 separate numbers there. And check out the 2 numbers. Square root of 4 is 2. Square root of 9 is 3. Sometimes it's going to be that simple. Okay? Now, sometimes it's not going to be. You get to number 5 and you're like, well, wait a minute. 2 and 3 aren't even on the list. Did I just say done? No. Because when we have radicals, you cannot have a radical in the denominator of your answer. We're going to make note of that. No square root in the denominator. So one of the rules that you learned way back when was what we call having to rationalize the denominator. In other words, we don't want this radical down here. How do I fix it? Whatever the radical is in the denominator, we're going to multiply both the numerator and denominator by it. You're like, now why would you do that? Why wouldn't you just do it to the denominator? Because I don't want to change the value of the problem. If you take something and divide it by itself, you're really just multiplying it by 1. So now when I multiply across, 2 times 3 is 6. 3 times 3 is 9, but the square root of 9 is a perfect square. And I can get there. Do we see this a lot moving ahead? No. But again, I got to have you prepared for it, just in case. So what we're going to do now is we're going to be getting to a point where we're using a square root to find the answer of things, which is why we just chatted about that for a minute. So we're going to solve the equations. And then here, x squared typically means there's going to be 2 answers. So get x squared alone is my first job here. Then take the square root. Don't take the square root before then. You got to have x squared totally alone first. So I get here and I'm like, well, x squared's already alone. Okay. Square root. Be careful. When you get to the take square root step, reminder, if I can remember how to spell remember, you're going to have 2 answers. So at whatever step you do the square root, that next step, put plus or minus in front of your answer. Because it is true that 4 squared is 16, but -4 times -4 is as well. And I got to get 2 answers. So I got to remember the plus minus part. Okay? So just keep that in order and we're fine. Working on getting x squared alone. Add my 3 over. Divide both sides by 2. X squared is alone. Take the square root. So now, 12. 12 is not a perfect square. It does not mean, what is the square root of 12? Let me punch it in here. Do not write plus or minus 3.46. Okay? Before I do the plus minus thing, I need to see if I can break the 12 down. So look at your list across the top. Do any of those numbers divide evenly into 12? Yes. 4 does. And since 4 does, 4 times 3 is 12. I can divide that into 12 if I'm not sure. Only the 4 gets out of radical jail because the only 4 is perfect. 2 square root of 3. And I'm good. Okay. So you see how we're kind of combining things here? We're doing the radical stuff, but we got to do our regular algebra stuff to get there. Okay. Let's keep rolling. Fractions, we don't care about no stinking fraction. Minus the 1 over. What's the opposite of dividing by 5? Multiply. Now, that doesn't mean we're going to have 5x squared. The 5 just cancels out the 5. Now we get to the step. Okay, x squared's alone. Take the square root. We're going to have plus minus. So now I look at this 35 and I start trying to divide numbers into it. I try 4, I try 9, I try 16, I try 25. Nothing's going in. What do I do? In that case, I can leave it alone. If nothing goes in, if I can't do it, I can't do it. And we just go on our business. Now, as there always seems to be in math, there's always an exception to everything, right? Nothing can ever just be one way all the time. So here, when we get down to 9 and 10, okay, now it's get parentheses alone is my number 1 job. Then I take the square root and get my plus minus. So it changes a little if there's parentheses here. I do not want to distribute. I do not want to FOIL this out. None of that stuff. So if the idea is to get parentheses alone, okay, multiplying by a third is the same thing as dividing by 3. If this said divide by 3, what would you do? You'd multiply both sides by 3 to get rid of the fraction. X plus 5 squared equals 21. Okay. Once we're there, take the square root. We're set with that. So over here, those cancel. Now I still have a number over here. I try to break down the 21, whatever's on the right side. In this case, again, nothing really does anything for me. So now you're like, okay, well, now what? Well, this is still algebra. What would you normally do if you're trying to solve for x? You'd minus 5. But here's where you've got to be careful. Okay? My 5 isn't under a radical. You cannot subtract it from the 21. This is in radical jail. The 5 is still free. Okay? We can visit. We can hang out. But you're not going in. So I just have to write the 5 ahead of it. Okay, I'd really prefer you don't put minus 5 here at the end. This mathematically is more of what your solutions would look like, again, on an exam, in a book, if you look up something online. So we'd really try to have it go this way, okay? So one more, same deal. Get parentheses alone. Divide by 5. I think you're going to like this one better. 125 divided by 5 is 25, okay? Parentheses are alone. Take your square root. Remember your plus minus. What's the square root of 25? 5. We're going to move me. Now we get a different instance that's a little bit interesting. Plus 1 plus 1. You're like, well, Hardy, wait. Why aren't you just putting it with the 5? Because the 5 is not under the radical. That's true, but this plus minus is still acting as a little bit of a wall. So stick with me here. I don't want to leave my answer this way. Okay? Mathematically speaking, I've done all the things I'm supposed to do. However, you're right. I can actually put these together this time. But if I'd have put them together right away and said plus or minus 6, notice that I got half the answer right and half the answer wrong. So I've got to make sure that I'm doing them separately, okay? Just so, this is why we keep this stuff out while we're working on it, just to make sure we're going good. You're like, oh, Hardy, don't do it. You're going to put applications in with this now? Yeah, but using the calculator usually makes it go quicker, so let's see. When an object is dropped, we've done this before. I have to use my other hand, just drop it. Its speed continually increases, and therefore its height above the ground decreases at a faster and faster rate. If you're on the top of a building and you drop something from it, it goes faster and faster as it goes down. It can be really dangerous, so don't drop things off the top of buildings. So we've talked about this before. End height, beginning height, gravity. And since we're dropping it, there is no initial velocity that I'm having to work with. So this model, again, only works on Earth. Moon, totally different place. So stuntman is working on the set of a movie, is going to fall out of a window 100 feet above the ground. There's my starting height. For the stuntman's safety, an air cushion 26 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. That's going to come into play here in just a minute. For how many seconds will the stuntman fall before hitting the cushion? Okay, question. We got gravity. How many seconds? We're going to be looking for t. We know where this started. Now here's the question. What number, how high is he going to be when he falls? I'm hoping you don't say 0 because we hope he doesn't hit the ground. If he hits the ground, we're in trouble. That's not going to turn out well. Which one of the numbers that are left here is going to do that? The width of the cushion? No. The length of the cushion? No. The height of the cushion. Read into this. Now, if you see a problem sometime that says to the ground, that's fine. Okay? You can absolutely use 0 there, but not in this case. So here, what I would suggest doing, everything to the t squared side. Now, is that my answer? No. We're going to get some help. Now, could I get this without the help? Maybe. We'll see here. Okay. Now, actually, I'll show you a couple of options here. So we're looking at this. I'm like, okay. Now, reminder to us, the only thing we care about is time, which is the x-axis, and when he's going to hit the cushion. Because we subtracted the 9 out, this is no longer going to be the ground. This is going to be the cushion. So I need to know what this value is. So if I go back to my handy-dandy help sheet again, handy-dandy help sheet, finding zeros, finding the x-intercept. Okay, we already have the equation in. Second, oops, let me move me again. I'm always in the way. Okay, there we go. So much stuff going on here. Okay, second trace, there we go. We want to find the 0, which is the x-intercept. Okay, now when our little cursor, again, is not there, don't worry about it. And we're only using the left and right buttons. This says we're at x equals 0. So we're like way up here now. And as I start moving to the right, notice the y value is coming down. We want that to get as close to 0 as we can. So we're going to keep hitting right. Cursor will show up. There it is. Oh, okay, that's as close to the x-axis as we're getting. That's okay. So once I'm there, 3 left arrow clicks. 1, 2, 3. It's okay if it disappears again, your cursor. Enter. Okay, there's our little border. All good. 6 right arrow clicks. 1, 2, 3. Okay, there's the cursor's back. Oh, there's the cursor's gone. 4, 5, 6. Enter. I've put both my boundaries in now to trap my x-intercept when I hit enter one more time. So approximately 2.38 seconds. Now, I'm going to show you one other option you'd have here. I always like to give you options with things. If you would have gone back to the beginning and your equation would have been like this, you do have the option, or we're going to find out if you have the option, of making 2 equations here. One with the right side and one with the left. And so what we would do in this case, we're going to test this out, because I always have somebody ask. Would that value right there tell me the answer if I wanted to do an intersection? If I did second trace intersect. Now you're like, okay, where is the first curve right now? I can't even see the cursor to know which curve we're talking about. So, okay, so right now we're on the blue. We're on the parabola. I hit enter. Okay, now the second curve would be my horizontal line. Oh, is it going to work? Oh, it does, because the x value is my time. So you can do it either way. You can either get everything on the squared side and find the x-intercept, or you can keep it as 2 separate equations and find the intersection, okay? You have options. One last piece to this. A movie camera operating at a speed of 254 frames per second records the fall. How many frames of film show the stuntman falling? Okay, so let's say I stick with this one. They are now telling me 254 frames per second, 2.38 seconds. 254 times 2.38. I can't do that in my head. Okay, now, let's chat though. I'm going to write down everything I see on the calculator here. 604.52. Now, frames. If you're doing a movie, you don't want a partial frame. It's going to make like everything rip. So, here in this case, we would round up because we want that last piece of our video. We don't want him like hanging there like a couple inches above the thing and we're in suspense. We're like, did he hit it? What happened? Did somebody pull it out? We've got to make sure. that we know these things. Okay. One last question, and then I will give you some time to practice here. And again, keep questions coming, especially on this stuff. If it's a calculator issue, if it's an understanding what numbers go where issue, keep questions coming. We can do them during meets. I can send videos out. We can make all sorts of things work here. Okay, we got our falling object model. So find the time required for an object that is dropped from a height of 100 feet and then 200. So negative 16t squared plus 100, negative 16t squared plus 200. And if I keep reading, reach the ground. So let's check this out. Clear everything else out of here. Negative 16x squared plus 100. Okay, we'll graph. Up and down. Okay, there's what I'm looking for. So again, second trace, up to 0. That's our intercept. Again, we're going to notice, okay, my x is about to 1. It looks like it's between 2 and 3, so I'll keep going. Or those are pretty close to the same thing, so either one will work. Again, 3 left, 1, 2, 3, enter. 6 right, 1, 2, 3, 4, 6, enter. And one last time for the guess. Okay, so 2.5 seconds. So what are we trying to figure out? Does an object that's dropped from twice as high take twice as long? So we're going to see if this one takes 5. So negative 16x squared plus 200. Now, this is just me. The question is, does an object that is dropped from twice as high take twice as long to reach? I can visually look at this right now and say 1, 2, 3. It's somewhere between 3 and 4. It's definitely not 5, which is way out here. So, like, I'm just going to jot this down right now. Between 3 and 4. Okay? Why isn't it taking twice as long? We chatted about this up at the top. Okay? The object goes faster as it falls. So like they'll be going at the same speed for that first 100 feet. When this one hits the ground, it's over. This one, it's going faster and faster as it goes. So it covered that last 100 feet in like half to 1.5 seconds. So it's going faster, okay? So little physics lesson in there for you today. You get a little science bonus in with your math. So again, just keep at it with this. Keep the stuff out when you're working on things, people. Don't put it away. This isn't a punishment doing this. It's so you know what you're doing, okay? But otherwise, again, keep going hard, keep going at it, and we'll see you next time.